All right, we're moving on to section 3, so page 472. This is new, yeah. The first part isn't terribly hard, but if you look at the first section, it says, the terminal side of an angle theta in standard position passes through the indicated point. Calculate the values of the 6 trigonometric functions for the angle theta. So, if we're looking at the unit circle, we know this is standard position, and we rotate counterclockwise would be a positive angle. Now the terminal side is basically wherever that dial stops. So we start in standard position, and it doesn't matter which way we spin. Wherever we stop is called the terminal side. So let's say that I stop right here. Okay, I have a circle. Okay. And it doesn't matter how I got there. How many different ways are there to end up right there? An infinite. You could rotate to there, or you could go all the way around and rotate there, or you could go backwards and stop there, or backwards a couple times and stop there. So if I ended up stopping at a point which was 7, 9, then I can build a triangle off of that, and I can find sine, cosine, and theta, or sine, cosine, and tangent, with theta being unknown. Okay, so I basically end up with a right triangle, and in that right triangle, what do I know about it? This is theta, the bottom is 7, and the side is 9, and so I need to find h. 7 squared plus 9 squared gives me 130, and the square root of 130 would be 2 and 65, 5 and 11, 12, 13. Can I pull anything out of that? No. So it just stays the square root of 130. So now, what is the sine of theta? 9 over the square root of 130, but I can't leave 130 on the bottom. So 9 root 130 over 130. Okay, what would the cosine be? So it's going to be 7 over root 30, which is 7 root 130 over 130. Okay, the tangent? 9 over 7. Okay, and then it says find all 6. So the cosecant of theta is just the upside down version of the sine. Do I want to flip this one upside down or this one upside down? The first one. So it would be the square root of 130 over 9. What about the secant? Square root 130 over 7, and the cotangent, 7/9. That's pretty easy, right? Okay. What if my point is negative square root of 5, 6? What quadrant am I in? That would be quadrant negative square root of 5 and positive 6 is going to be right here. So negative square root 5 and 6. Everybody get that? Okay. The hypotenuse is going to be 6 squared plus square root of 5 squared is just 5. So the square root of 41. So here's theta. Well, actually theta is right there, but it doesn't matter. So the sine would be 6 root 41 over 41. The cosine would be negative root 5 over root 41. How do I convert that? Would be negative root 5 times root 41 over 41. And then I would multiply the 41 and the 5 together. Right, that would be 205. So it would be negative square root of 205 over 41. And then I need to check, does 205 simplify? Well, it's 5 times 41, and 41 is prime. So you may have to simplify after you combine. And you guys know how to do that, right? I did. That's okay. Didn't ask if you liked it. I just asked if you knew it. Okay, and then tangent would be 6 over negative root 5, but you'd need to convert it. And then cotangent and cosecant and secant can also be found. Can you guys handle those, or do you need to see another one? Okay. Yeah, you need all 6. Sine, cosine, tangent, and then cosecant, secant, and cotangent. Yeah. All right. Look at 15 through 24. Indicate the quadrant in which the terminal side of theta must lie in order for the information to be true. So we're going to go through 16 through 24 together, and then you can do 15 to 23 on your own. So number 16, cosine is negative and sine is positive. Where does that happen? Well, let's think about it. So this one is plus plus. What happens in quadrant 2? Minus plus, and then 3 minus minus, and then 4 is plus minus. And we know that the sine is equal to which value? Sine is opposite over hypotenuse. So if I drew a triangle, O over H, and H is 1, would just be the Y value. Do you guys remember that? And that's why we call it the unit circle. We turn the H into 1, and then we don't have to divide by 1 anymore. So sine is the Y value, and cosine is the X divided by H, so X. And then tangent is simply Y over X, because it's the Y value divided by the X value. Okay, so we come up with this mnemonic. All students take calculus, which isn't true, but that's how the calculus students say it. Everybody else says all suckers take calculus, which also isn't true. I knew a lot of suckers that weren't in calculus. So we can actually use that all students take calculus and not have to worry about the positives and negatives. So number 16, cosine is negative and sine is positive. All students take calculus tells us which ones are positive. So they're all positive in quadrant 1, sine is positive in 2, tangent is positive in 3, and cosine is positive in 4. So where is the cosine negative and the sine positive? 2. Okay. Number 18, tangent is positive and cosine is negative. 3. 20, secant and cosecant are both negative. Well, the secant matches up with the cosine. Are the signs any different? No, they're just reciprocals. So if cosine is negative, secant is negative. So we need to know where the sine and the cosine are both negative. That would be 3. Cotangent and sine are both negative. That would be in, what'd you say, Brent? 4, right. And then cotangent is negative and cosecant is positive. So that would be where tangent is negative and where sine is positive, which is 2. Okay. All right, look at number 26. 26 says, if the tangent is negative 5 over 12 and the terminal side of theta lies in quadrant 2, find the cosine of theta. So I draw my unit circle, and where am I? In quadrant 2. So I'm right here. So that's my theta. Okay, and I know that the value of this point is what? Negative 512. Why is it not 5 negative 12? X has to be negative. So if the tangent of theta is 5 over 12, this doesn't tell me which one is negative, right? But I know that tangent is O over H, or sorry, O over A, and O is negative in quadrant 2 and A is positive. So this would be negative 5 and this would be 12. Okay, what am I looking for? Find the, it's actually cosine, we're on 26. Find the cosine of theta. So I want to know this one. Yeah, don't worry about theta. Theta just, so most of the thetas we deal with are in quadrant 1 when we have right triangles, but on the unit circle, it doesn't really matter how you got there. Theta could be this or it could be that. It doesn't matter. And actually, we're never going to calculate what theta is, so we don't worry about it. So we just know that we're in quadrant 2. So I need to find h. 5 squared plus 12 squared. That's equal to 169. Does anybody know what the square root of 169 is? 13. So h is 13. The answer would be negative 5/13, because that's the cosine. Okay, look at 28. The cosine of theta is 4 over 41, and we're in quadrant 4. Find the tangent of theta. So we're in 4. So the cosine of theta is 40 over 41. Is that right? Okay. So how do I label this triangle? What is 40 and what is 41? The x value is 40, and the hypotenuse is 41, and I want to know what the tangent of theta is. So I need those two. So it will be 41 squared minus 40 squared. 41 squared minus 40 squared, maybe, is 81. So the adjacent is, no, negative 9, because we're in quadrant 4. So this is negative 9. So the tangent of theta would be negative 9 over 40. Yep. Okay. So today I just want you to do 472, 1 through 35 odd. Good luck.